Now, another feature that is useful to look at when considering the spread of the data in a sample or in a population is to look at the z-scores for a particular value. Now, the z-score is the number of standard deviations that a datum or given piece of information within that population is from the mean. So if you're going to calculate the z-score, you do that by dividing the deviation, and remember that the deviation is going to be the distance a data value is from the mean. So here for the population, it is the value of that piece of data minus the mean, and that'll give you the deviation from the for that particular value, and you divide it by the standard deviation, and that will give you the z-score. Now, if a value is exactly on the mean, so let's say that the value x is equal to the mean, then we're going to get a z-score of 0, which means that it is going to be 0 standard deviations from the mean. However, if the standard deviation is 2 and this is 4, the mean is 2, and the standard deviation is 2, then this is going to be 4 minus 2, which is 2, over 2, which is going to be 1. And in that case, the standard deviation of 1 means that if this was 4, then that's 2 above the mean, and the standard deviation is 2, so that means that it is 1 standard deviation above the mean. And the same principle holds for the z-score for a sample. It's going to be the value of that data point minus, in this case, it's going to be the mean of the sample divided by the standard deviation of the sample. So we'll take a look at an example here. And so if you're calculating the z-score for a sample of fish taken from a lake, now the mean length of the fish was 14 inches and the standard deviation was 4 inches. You want to determine the number of standard deviations each piece of data the number of standard deviations each piece of data lies above or below the mean. So we've got a data value of 11. So our z-score, remember, is going to be the value of that piece of data minus, and here the sample population, the mean of the sample population is going to be, and I'll write this out as x bar over s because we're talking about a sample here. Same calculation holds if it was, would hold if it was a population. It's the same idea. So this is going to be 11 minus 14 all over 4. And so this is equal to then negative 3 over 4, which is negative 0.75. And so that means that this data value, 11 inches, is 0.75 or 3/4 of a standard deviation below the mean. If this was 10, for example, well, then this would have been 10 minus 4. So the z-score would have been 10 minus 4 over 4, which would have been negative 1. And in which this case, this negative 1 would have meant that the standard deviation, or the value of 10, is 1 standard deviation below the mean. And that makes sense because if the mean is 14 and the standard deviation is 4 inches, then it's going to be 1 standard deviation below the mean would be a fish that has a length of 10 inches. Now, if we have a case where one of the fish caught was 21.5 inches, then the z-score for this is going to be 21.5 minus the mean, which is 14, all over 4, which, call for calculator, divided by 4, into the order of operation. So this is going to be then 1.875, which is pretty close to 2 standard deviations above the mean. And recall here that if the mean is 14 inches, 1 standard deviation above the mean would be 18 inches, and 2 standard deviations above the mean would be 22 inches. So that means that a value of 21.5 is 1.875 standard deviations above the mean. So, next question. Kaylee scored 84 on her data management course, while Lauren, who attends a different data management class, scored 83. If Kaylee's class average is 74 with a standard deviation of 8, and Lauren's class average is 70 with a standard deviation of 9.8, use z-scores to determine who has the better mark. And the z-score is going to indicate this.